What if I told you? Most people think batteries are just dead waste when they stop working. But in reality, a large part of what we call battery recycling is actually careful material recovery, energy system breakdown, and controlled reprocessing of valuable metals and components that can be reused again in new energy systems. And in off-grid living, understanding how battery recycling works is not just environmental. It's part of long-term cost survival, safety, and system planning. At the beginning, you need to understand what recycling a battery actually means. A battery is not a single solid object. It is a combination of metals, chemical compounds, plastics, separators, and in many cases, electronic control systems like a battery management system, BMS. When a battery reaches end of life, it doesn't mean everything inside is useless. It means the battery can no longer reliably store or deliver energy at its rated capacity. But inside it still contains recoverable materials like lithium, cobalt, nickel, copper, aluminum, and steel, depending on chemistry. Now, let's break it down by battery type, because recycling processes are completely different depending on chemistry. For lithium-based systems like LiFePO4 or lithium-ion, recycling starts with safe discharge and stabilization. This is one of the most important steps because lithium batteries still hold energy even when dead, and that makes them potentially dangerous. After discharge, batteries are mechanically dismantled or shredded in controlled facilities where materials are separated into fractions. Metals, plastics, and chemical black mass. That black mass is where most valuable elements are recovered, later through hydrometallurgical or pyrometallurgical processes. Basically, chemical leaching or high-temperature smelting to extract usable raw materials. For lead-acid batteries, recycling is more established and highly efficient. These batteries are usually broken down mechanically, where plastic casings are separated, lead plates are melted and refined, and acid is neutralized. Lead-acid recycling is one of the most successful recycling systems globally, with a very high recovery rate of lead and plastic, making them one of the most circular energy storage technologies in existence. Now let's talk about what actually happens in proper recycling facilities. Batteries go through several stages. First, sorting and identification, because different chemistries cannot be processed together. Then discharge and safety handling, followed by mechanical separation, and finally material recovery. In advanced facilities, recovered materials are refined to near new purity and reused in manufacturing new batteries, closing the loop between old energy storage and new production. But here's something most people don't realize. Not all recycling is actually full material recovery. In many cases, especially in smaller systems or informal handling, batteries are instead repurposed before recycling. This is extremely common in off-grid environments. For example, EV batteries that are no longer suitable for vehicles are often reused. This is called second life battery use, and it is one of the most important bridges between first-use performance and final recycling. In off-grid setups, second life batteries can still power solar systems, cabins, workshops, and backup storage, often at reduced but usable capacity. This extends lifespan dramatically and delays the need for full recycling while reducing cost. However, it also requires careful testing because degraded cells may have uneven performance or reduced cycle stability. Now, let's talk about the environmental and safety side. Batteries should never be thrown in normal waste streams because they can leak toxic substances, cause fires, or release harmful chemicals when crushed or exposed to moisture. Even modern lithium systems, while cleaner than older chemistries, still require controlled processing to avoid environmental damage and fire risk. Another important concept is collection infrastructure, which determines how effectively batteries actually get recycled. In many regions, recycling depends on designated drop-off points, manufacturer take-back programs, or certified recycling partners. Without proper collection systems, even recyclable batteries often end up improperly stored or discarded. Now here's the deeper insight most people miss. Recycling is not just the end of a battery's life. It is part of the design cycle. Manufacturers increasingly design batteries with recycling in mind, choosing chemistries and structures that are easier to dismantle. This is especially important as global demand for lithium and other materials increases. In real off-grid thinking, recycling also connects directly to system planning. A well-designed system doesn't just consider how batteries perform when new. It considers what happens when capacity drops to 70 to 80%. Whether batteries can be repurposed, how easy replacement is, and how materials will be handled at end of life. Because in long-term energy independence, nothing lasts forever, but everything should have a planned second use or recycling path. Now here's the real takeaway. Battery recycling is not just waste management. It is energy recovery in reverse. It turns used storage back into raw materials, and in some cases, usable second life systems that continue powering real applications. And if you understand that cycle, you start to see batteries differently, not as disposable units, but as part of a continuous energy loop that moves from raw material, gives storage, gives usage, gives recovery, gives reuse, gives back to production again. If you want more deep, practical breakdowns like this about solar systems, make sure to subscribe to my channel, Off Grid Life Tech.